Alrighty, we are back for another set of state test questions. Today's standard S.ID.2, second standard in statistics. So let's hop right in. Question 1 from the Spring 2017 OST. What statistical measure changes when every number in a data set is increased by 10? So we have the range, we have the mean, we have the standard deviation, we have the interquartile range. So let's take a set of data. We can do a small one. 0, 5, 10, 15, 20. Okay. If you do that, the range is 20 minus 0, which is 20, right? Your median would be 10. Your quartiles would be 2.5 and 17.5. That would be a difference of 15. Your mean would be 5 plus 10 is 15, plus 15 is 30, plus 20 is 50, divided by 5 total numbers. Your mean would be 10. We'll worry about standard deviation later. Let's increase all these by 10. 10, 15, 20, 25, 30. And I'm hoping that as I write that down, the answer becomes obvious to you. Because what is a mean? A mean is an average. In the last example, our average was 10. In this example, our lowest number is 10. There's no way that our mean can be 10. Your mean would in fact be, I believe, 20, 25, 45, 70, 100. 100 divided by 5 would be 20. This would be mean. Question 2. A gym teacher compares the points scored by 3 basketball teams in their last 11 games. The points scored by Team A are shown. The scores of Team B and Team C are shown by the following box plots. Okay, select a box in each row of the table to compare the median scores and the interquartile ranges of each score. All right, so Team A is written out in a very unfortunate fashion, in the fact that the data itself is written out. Okay, it's not in a fancy box and whisker plot, which is easy to read for the purposes of interquartile and range and median. So, however, we can use Desmos. Okay, if I go to Desmos and I click in the top left here and I hit plus table, this will allow me to put in data. So I can put in Team A's data. So we had 62, 72, 74, 74, 76, 78, 82, 85, 88, 88, 92. Okay? Those are our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is that 11? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 points of data. Okay? And now on Desmos, you can hit this wonderful button called Stats. You just type in stats. I'm putting in X1 because the name of the column with my data is X1. So this will give me my 5-number summary. My minimum is 62. My Q1 is 74. My median is 78. My Q3 is 88. And my max is 92. The range is your maximum minus your minimum. So your range here would be 30. Your interquartile range, I should be back on the page. The interquartile range is your Q1 minus your Q3. So that would be 88 minus 74. I'm going to abbreviate this IQR. 88 minus 74 is 14. Now, we can use the box and whisker plots to find the information for B and C. Min, the Q1, the median, the Q3, and the max. Okay? So, B's Q1, or B's minimum, reasonably estimated at 68. Okay? And a reasonably estimated 68, C's would be in the same spot. Team C's Q1 would be at 70. Team B's Q1 would be at 78. I'm going to say 78. Team C's median is at 82. Team B's median falls at 86. Team C's Q3 falls at 86. Team B's Q3 falls at 90. Team C's max falls at 90. And Team B's max falls around 92. So, what do we do with all this information? Well, Team B and C have a interquartile range and a range. The range for Team B would be 92 minus 68. Let me double check my math here in Desmos. 92 minus 68 is 24. Team C's would be 90 minus 68, which would be 22. The interquartile range, Team B would be 90 minus 78, which is 12. And Team C would be 86 minus 70, which is 16. We now have all the information we need. Which team has the lowest median score? Team A has 78. Team B has 86. Team C has 82. That would be Team A. Who has the highest median score? Team A has 78. Team C has 82. Team B has 86. That would be Team B. The smallest interquartile range of scores. Team A's is 14. Team B's is 12. Team C is 16. So that would again be Team B. And the largest interquartile range, Team A is 14, Team B is 12, Team C has 16. So it would be Team C. Rashid and Valentina each read 10 books. The total number of pages of each book they read is represented in the box plots below. Okay, what is the difference in the median number of total pages per book that Rashid and Valentina read? So, remember, in a whisker plot, your median is the line in the middle of the box. So Rashid's median would be roughly 350. And Valentina's median would be 300. 300 minus 50, because you're looking for a difference, is 50. That question takes 5 seconds. Question 4. In a random survey, customers rated 2 products of a company on a scale of 1 to 10. The dot plots show the result of the survey. What is the difference between the ranges of the 2 plots? So if you've never seen a dot plot before, each dot represents 1. It's kind of like a histogram, but instead of bars, they use dots. Okay? But we're not really analyzing too much about what's in the middle of this. All we need to know is what is the difference of the ranges. And we know that the range of data is the max, minus the min. The highest minus the lowest. For product A, our range is 10, because that's the highest, minus 1, which is the lowest. The range is 9. For product B, the highest is 10, minus the lowest, which is 3. That's 7. The difference between the ranges is 9 minus 7, which is 2. Question 5. Mr. Cooper asks the students in his 5 classes how many pages they read in their books last week. He creates box plots with the data. The box plot for class 5 is shown. Which class's box plot has an interquartile range that is equal to class 5's interquartile range? So all this is asking is, what is class 5's interquartile range? It's the difference between Q3 and Q1, the length of the box itself. 40 minus 20 is 20. So looking for another class that has an interquartile range of 20. I can tell you immediately it's not class 3, because that is way too small. Class B has 25 to 50. That's an interquartile range of 25. Class 1 has 15 to 30. That's 15. Class 4 has 30 to 50, which is 20. It is class 4. Question 6. Pull this down a little bit so I have more. Here we go. The average high temperatures in degrees Fahrenheit for 6 months in 2 cities is shown. Molly wants to live in a city that has the least variation in temperature over the 6 months. Complete the sentence to describe where Molly should live. Okay, so when you are looking at wanting to have least variation, what you're going to look for is the standard deviation. This is one way to represent how much variance you have. Okay, I believe that Desmos will take care of standard deviation for you if you put in the data. So let's put in the data table. So I have to pick up the paper, otherwise I can't read the data. 33, 36, 46, 57, 67, 77. Meanwhile, Hawaii, 79, 79, 80, 81, 83, 85. Now, based off of this, just looking at this data, you should be able to tell me which one of these has, less variance. The second column for Honolulu goes from 79 to 85, while this first column, which is Chicago, goes from 33 to 77. It is going all over the place. But you can put in the standard deviation of x1 and the standard deviation of y1, because that's our second column. And you can see that y1 has a significantly lower standard deviation than x1. So this would just be, if you want to have it be more consistent, she should live in Hawaii because it has a lower standard deviation. And that is it. So that's going to do it for this standard. If you have any questions, feel free to let me know. Otherwise, good luck on your test.